All right, so in this video, we're going to be looking at decimal representations and other bases. So when we represent something as a fraction, we don't necessarily worry about what base our fraction is in. But when we represent something as a decimal, then we're going to represent something as in base 10. And so essentially, we're creating a sum of fractions where the bases of our fractions are the powers of 10 in the denominator. So 3 divided by 8, and this is a terminating decimal, but 3 divided by 8 is going to give me 0.375. And so what does that mean in decimal representation in base 10? That means that I have 3 multiples of 1/10, and I have 7 multiples of 1/100th, and then 5 additional multiples of 1/1000th, and then I don't need anything else. So how would I represent this in, let's say, base 6 or base 11? Now, in base 6, remember that our decimals are going to be equivalent to powers of 6. So we'll have some number over 6 plus some other number over 36 plus some other number over 216 plus ... And so essentially, again, our numbers that go in our numerators can only be numbers that are in the base. So in base 10, we can have numbers anywhere from 0, if we skip over a term, to 9. 0 to 9, that's our 10 digits. So in base 6, we can only have numerators that take on values between 0 and 5. 0, 1, 2, 3, 4, 5. And then that's it. So one way we can think about this is if we're looking at 0.375, what is the, when we're looking, we start with 1/6, which is the largest power, the largest fraction, essentially. And we want to figure out the multiple of 1/6 that is still smaller than 0.375. Now, if I take 1 divided by 6, that's only 0.1666666. What about 2 divided by 6? Well, that's 0.33333. I think we're going to end up with that. If I do 3 divided by 6, that's 0.5. So again, it might be useful to think about these decimal representations. 1/6 is 0.1666666. 2/6 is 0.33333. 3/6 is 0.5 in decimal form. 4/6 is 0.66666. And then 5/6 is 0.833333. So those are our options. 0.333 is clearly smaller than this one, and so that's where we're going to go with this. So we're going to essentially have 2/6 as our decimal form plus some remainder. So when we're doing this next set of calculations, we're going to take our 0.375 and we're going to subtract the 2/6. And so the remainder is going to be 2/6 plus 0.4166666. I'm going to say that seemed bigger. So now we're going to move on then to multiples of 1/36. And again, we only get 0, 1, 2, 3, 4, and 5 multiples of 1/36. So what is 1/36? One divided by 36 is 0.27777. What about 2/36? That's 0.2 0, sorry, there's another 0 there. 0, 5, 5, 5, 5, 5. I don't really need to list anymore because this is already too big. So I'm going to have one copy of a 1 over 36. And then what's left over. So I'm going to take my 0.375 minus 1/3, my 2/6, and I'm going to subtract off another 1 over 36. My remainder is now 0.013888888. So now I go on to my next round, 1 over 216, my next level fraction. Well, what's that going to be equal to? 0.04629, blah, blah, blah. 00, sorry. What about, and again, I can only go up to 5. So 2 divided by 216 is going to be 0.009259, blah, blah, blah. What about 3 divided by 216? 0.013888888. There we go. There's our fraction. Now, if we were not getting to a place where there's exactly an exact number of an exact match between our fractions, then we would keep going forever. But here we've come up with 3 over 216 as the rest of our fraction. And so in decimal form, again, we would represent this as 0.213 base 6. Remember, our digits in the decimal form can only take on 0, 1, 2, 3, 4, and 5 in base 6. And so we can only have multiples, 1 through 5 multiples of 1/6, 1/36, 1 over 216, and so on. Now, decimals obviously could continue as being, they could continue indefinitely. I mean, we see that in decimal form all the time. Things that don't divide evenly, denominators that don't divide evenly by 2 or 5 are going to get continuous decimal expansions. And the rules are going to be slightly different when you're in base 6 versus base 10, obviously. But we ended up in this case with an exact decimal representation of 3 over 8 in base 10 represented as 0.213 in base 6. Now we can do a similar procedure for 1 over 11. And so let's actually do that base 11. Now in base 11, of course, we're looking at 1 over 11 multiples, and 1 divided by 11 is 0.0909 ... And then 2 over 11 is 0.1818 ... And then 3 over 11 would be 0.2727, and 4 divided by 11 would be 0.3636, and 5 over 11 would be, there's a decimal place in there, would be 0.4545, dot, 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 and so on, up to 10 out of 11, which would be 0.9090, dot, dot, dot. Now, for base 11, of course, we cannot represent 10 as 2 digits in base 11. So we can use something like X, or we can use T to stand for 10. So we have that extra digit for in case we need base 10 for this, 10 multiples of something. Now, in this case, we're starting out with 0.75. And so this is the largest decimal version of some number over 11 that is less than our 0.75. So our first breakdown is going to be 4 over 11 plus some remainder. And that remainder is going to be 0.375 minus 4 divided by 11. And we're going to end up with 0.01136, blah, blah, blah. So then our next power of 11 is 1 over 21, 121. So 1 over 121. And we need to find out how many of these we're going to need. So 0.00826, blah, blah, blah. And then 2 over 121 is going to be 0.016528, blah, blah, blah. And I'm already bigger than this number, even here. So I'm going to need just one copy, 4 over 11 plus 1 over 121 plus what's left. So 0.375 minus 4 over 11 minus 1 over 121. And now I have 0.003099 and stuff. So what is the next power of 11? 11 cubed is 1 over 1331. So we're going to end up with 1 over 1331 is going to be 0.000751. And things may get a little bit confusing in your calculator because they are now converting to scientific notation. So 2 over 1331 is going to be 0.001502. And 3 divided by 1331 0.00222539 dot, dot, dot. And then 4 over 1331 0.003003 5, 2 stuff. And I think this is where we're going to stop, but let's just double check. 5 divided by 1331, too many threes. We've got 0.003756, blah, blah, blah. Yes, so that is bigger than what we have left, our remainder. And so we can stop here at 4. So now our decimal representation, we've got 4 over 11 and 1 over 121 and 4 over 1331 and then some remainder that's left over. And let's find out what that is. And so we take our original 0.375 and we subtract off what we've accounted for. And we end up with 0.123493914 ... And I'm going to figure out what the next power of 11 is. So 11 to the 4th is going to be 14,641. So 1 over 14,641 is 0.1234683, blah, blah, blah. And 2 over 14,641 is 0.1231366, blah, blah, blah. And so we just need the 1. And so it'll be these plus 1 over 14,641 plus some remainder. And it's really looking strongly like we're starting to see a repeated pattern. And so our decimal would be represented as 4141. And then we would have some additional ones, but it actually looks to me like it's going to be repeating 4141 in base 11. So again, you can do decimal representations in bases other than base 10, and they work more or less the same way that our original fractions do. If I want to think about how base 10 is actually working with a 0.375, again, think about my original representation as 3 over 8. I'm looking for a multiple of 10, 1/10, that is going to be less than 3 over 8. 3 over 8. So 3 over 8, I could, again, in my calculator, 3 divided by 8 minus 1 divided by 10. I could, and then when I know when I've gone past where I need to go, when I get a negative number. So 3 divided by 8 minus 2 divided by 10, still positive. 3 divided by 8 minus 3 divided by 10, still positive. 3 divided by 8 minus 4 divided by 10. Oh, no, that's negative. So I'm going to need 3 over 10. And then 3 divided by 8 minus 3 divided by 10, my remainder in fraction form is 3 over 40. And so now I'm looking for what are multiples of 1 over 100 that will be less than 3 over 40. So again, I can take 3 divided by 40 minus 1 divided by 100, and then that's still positive. 3 divided by 40 minus 2 divided by 100. That's still positive, and I can keep going like this. And when I get to 3 divided by 40 minus 8 out of 100, I go into the negative region. So that's why I know that I have to stop at 7 over 100. And then I would, again, keep going until I either cleared my entire fraction, which is what I end up doing, or I decide I've seen enough and I'm going to stop at this representation. So in this case, we do end up terminating like we did with base 6. We have exactly 3 digits in our decimal, 0.375 in base 10. But we saw that with base 11, we end up repeating. And so we stopped after it was clear that there was a repetition.